Hey there, this is Akshat Madan, and from 4 years I have been creating development projects, full stack projects, mobile projects on this channel. But a lot of you told me that in interviews they are also asking DSA, and you are not very strong in DSA. And I don't want to create another series of DSA videos because there are like thousands of creators who have created great videos on DSA on YouTube for free, right? So the main purpose of creating this series or creating this video is to showcase you how you can actually utilize data structures in your full stack applications. So I want a feedback from you whether you want such videos or not, where I pick a data structure or I pick an algorithm, and based on that I teach that, and based on that I create a full stack project. It can be a mobile app, it can be a web app, it can be any model, it can be any script, right? But the base will be a data structure, so that you actually understand the use case of that data structure instead of just remembering the time complexities and space complexities, right? So I want you to use data structures in your development projects so that your projects are scalable and highly maintainable and they're efficient, right? And you can actually mention in your interview that, hey, I use this data structure or I use this algorithm in my full stack project that is there in my resume. So this is the purpose. But if you want me to continue this series after this video, I want at least 100 likes on this video so that I understand that you really want such projects where I use a data structure and an algorithm at the base. Okay, so that's one. Now coming to this video, what I have created in this video is a file searching and uploading system where you upload a file, it gets stored in a binary search tree. Okay, I am going to store this file as a node of a binary search tree with some metadata and with some name, file name, right? Now I'm going to apply search on this binary search tree to find my file. That is going to take multiple times lesser time than if you store the file names in an array, right? I'm coming to that. Don't worry if you are not understanding anything. I'll give you examples, right? So basically my main aim of creating this video is to showcase, show you the efficiency of a binary search tree where you want to apply searching, right? When you want to apply searching, binary search tree is a very efficient data structure, right? So if I show you an example, I have this folder where I have 100 files. Okay, now you can just hit Command F so that this Command F or Control F so that this searching field comes up. Now if I search CAV, you can see that it is giving me so quickly, it is giving me the file name which starts with CAV. Okay, do you think they would have stored all of these file names? VS Code would have stored all of these file names in an array? If they would have stored in an array, and let's say there were like 1,000 files in my system, it would have taken a lot of time to search my file. But in a binary search tree, if they would have stored all of these file names in as nodes of a binary search tree, then it would take a lot lesser time. How does that happen? Let's try to figure out that, and then let's create this web application. So I'm going to create a server in Node.js where we create a schema of my binary tree, where we create a service to upload my file, we store the uploaded files, we create a simple express application, and my backend will be ready. Okay. Then I have created this client in Next.js. Don't worry if you don't know Next.js. I've tried to make it very simple, right? Where we have 2 pages where you can actually first of all upload a file, search a file, and then you can also visualize your binary search tree. Okay, let me show you how it is working right now. It might look simple, but believe me, if you watch this video end to end, you will find yourself in a very different situation, and you will actually understand the significance of data structures, and you will start implementing and using it in your projects. So if I try to search a file that is not there in my local database, right? So if I search for a.txt, so this file is not there in my uploads folder. If I search, it says error searching a file. But if I actually pick a file that is already there, that I uploaded in my system, if I copy this name and if I try to search this, you can see the file is found. And I can also upload a new file. Let's say I upload this cdt, upload, and I can upload it. So file uploaded, and you can see it is appearing over here. So you think that, hey Akshay, why are you creating this such a basic project? Believe me, once you go through the schema of binary search tree and inserting algorithm and searching algorithm, you will understand a lot, and you will actually understand the end significance of these data structures. Believe me, please follow this video. Okay, so this is like one thing where we are uploading a file, we are searching a file using binary search tree, traversal algorithms, and we can also visualize our binary search tree like this. Okay, there is one issue. Okay, yeah, this is like view tree, not show tree. You can see this is my binary search tree. Don't worry, I'm going to go through it one by one and we will understand it. Now, first of all, let's understand how binary search tree works so that we can go ahead and write the code for it. So, first of all, understand the significance, right? Let's say you are having an array, right? Array. First of all, we are working with an array data structure, right? Where you have places where you can insert data. Let's say in our case, we are inserting files. Let's say you inserted file number 1 here, file number 2, file 3, file 4, file 5, file 6, file 7, and file 8. Let's say there were 1,000 files that you had to upload. Okay. Now the file that you are searching, let's say it is present at the end part. So this is the file and it is present at 1,000th item this is. So if you want to apply a search, if you want to find a file, whether this file is present in your data structure or not, then you have to go through one by one. You will start from here and then you will go till here. And let's say hypothetically, one iteration from here to here takes 1 second. So can you tell me how many seconds will it take to find your file? Yes, it is going to take 1,000 seconds. Why? Because the time complexity of an array searching in an array is big O of n, the worst case, right? Because it can be present at the end and for every iteration you take 1 second and you have to go through all of the items. Then you will find your item at the 1,000th position. That's why the time complexity of searching in an array is big O of n. So that's why 1,000 seconds, right? But let's say, let me write it nicely, 1,000 seconds. Okay, but let's say we were using a binary search tree. So how does a binary search tree works? Okay, so a binary search tree starts with a node. This is a node. Okay, a node has two things, actually three things. It has some data, it has left child, it has a right child. Okay, so it has a left child, it has a right child. That's not compulsory, but it can have two child. And a binary, that is binary, it can have a maximum of 2 children only. Okay, so it will have a pointer to my left child and it will have a pointer to my right. So these are like pointers. Okay, so pointer to my left child, pointer to my right. Okay, and it has data. Data will store the file name. Okay, data will store the file name for our case. Okay, then again, this is a node, right? This is a node, and these are all nodes itself. These are all nodes. Every node is going to look similar. So this node will also have my data, and it will have left child and it will have right child, right? So again, like this. Okay, this node will also have a left child and a right child. Okay, and again, these will also have left child and right child. I mean, may have. Okay, they can be null also. Okay, so like this. Now, this is a complete tree data structure. This is a tree. This is not a binary search tree. If you want to make it a binary search tree, you have to implement one more. You have to have one more condition, that the data or the value of my root node will always be greater than the data of left node. Okay, and the data of right node will always be greater than the data of my root node. Okay, and it is always be greater than the data of my left node. That means my data of my left node will always be the smallest. Okay, so if I come back to my binary search tree and if I say that this is a binary search tree, and if we start putting some data in it, let's say we put 8 in this, or it can be numerical data, it can be alphabetical data. In alphabetical data, we will compare the alphabetical order, right? Z appears after A, like that. Okay, so if this is 8, then this has to be something lesser than 8 because this is a left child. For the right child, it must be greater than 8 because this is a right child. Okay, now the next 6. So it can be 4 because it has to be, because this is a left child of 6. So this must be smaller than 6. And because this one is a right child of 6, so this must always be greater than the 6, right? So it can be 7. Okay. Then coming to the 10. So the 10, the left child should always be smaller than 10. So it can be 9. Then the right child of 10 will always be greater than 10. So it can be 12. Okay. Now coming to left child of 9. So it should always be smaller than 9. So it can be 8. Okay. Then the right child of 9 should always be greater than 9. It can be 11. Left child of 12 should always be smaller. So it can be 10. Now the right child of 12 should always be greater. It can be 14. Okay. Great. The purpose, the advantage of using a binary search tree instead of an array, you see array is so simple, but binary search tree is so complex. So what is the advantage? You must know binary search for that. So what happens in a binary search? Let's say you are given an array itself. Let's start with an array. Okay. Let's say you are given an array where you are given some numbers, a sorted array. Okay. A sorted array. Let's say 3, then 6, 8, 11, then 12, then 16, then 18. And you are trying to search your client, your user search 16. Okay, this is the number that the user is searching. So what you do is you go to the center of your array. Okay, and then you see whether this element 11 is greater than the element that you're trying to search or smaller. It is smaller. Or it is equal, right? Is it smaller, it is equal, or it is greater? It is smaller. That means because this is a sorted array, then 16 should always be appearing on the right hand side, not on the left hand side, right? So you can nullify or you can mark these items as not found directly. In just one iteration, you just removed half of the items. Okay. So your item will always be on the right hand side, right? So 12, 16, again, you do recursion, right? You know recursion, right? You again apply the same thing over here. Find out the search, find out the middle item. Whether 16 is greater, equal, or smaller. It is equal. So in the second attempt itself, you found your index, that where your search item is present. The same concept is applicable in binary search tree. Okay, let's say you're trying to find 10. Okay, let's not take 10 because by mistake I took all the values, some of the values as similar. Let's say you're trying to find 14. 14 is the number that you have to find out in this binary search tree. So let's start from root node. This is my root node 8. You see whether this root node is greater than the key item that you have to find or smaller, or is it equal? It's not equal for sure. So 14 is greater than 8. That means 14 will never ever lie on the left side of my tree. It has to always lie on the right hand side of my tree. Okay, because right child will always be greater than the root node. So now this is the area that I am interested in. Okay, let me erase some of the parts. So now this is all gone because this will never be appearing over here. Okay, now this is my leftover tree that I have to search. So I go to so I go to 10. Is 10 greater, smaller, or equal? It is not equal. So this is not the item that I am finding out. This is not the index. So 14 is greater than 10. So that means 14 will never lie on the left side of the tree of 10. Okay. So that's why I can remove this whole part. This is not important for my search, right? Next attempt. Let's go to the next attempt. Go to 12. Okay. Now 12. Is 12 equal, greater, or smaller than 14? It is smaller. Okay. That means 14 is greater than 12. So 14 will never ever lie on the left hand side of 12. So this can whole be removed. Okay. Fourth, you go to the next. You see 14 is there. 14 is equal to the item that you are finding out. So this is the index. So your item is found. Item is found. In the fourth iteration, the fourth attempt, your item is found, and your function will come out of recursion and it will give you the index, or it will give you the location. Okay. But instead of array, if you would have like 10 items, then your time complexity is 10. You have to go through all of the items. Yes, it could have been found earlier, but in the worst case, in our worst case also, because we took the worst case, right? 14 was at the end. It was a leaf node, but we still found 14 in the fourth attempt itself. But if in an array, if your item was present at the last element, it has to go through all the elements. But over here, we were able to reduce half of the tree every time, right? So that is why it reduces like this: n by 2 in the first attempt, n by 4, then n by 8, then n by 16, like this. So that's why the time complexity of a search in a binary search tree comes out to be big of log n. Okay. Okay, so if you take base 10, then if in an array it was taking 1000 seconds, then in binary search tree it will take 3 seconds. Okay, you see what's the difference? Great. So this is the theory of the complete binary search tree that I want to teach. Now let's go ahead and start writing the code. So first of all, we will start with the server, then we will start with the client side. Okay, great. Let's go ahead. Best of luck. So let's get started. So first of all, I'm on my VS Code and I've created a folder called DSA Dev Projects. So in this, I'm going to create one folder that will be my project folder. So the name of this project is BST. And as I told that, if you guys are interested, I can create more such full stack development projects using data structures, so that we learn data structures by actually building full stack projects. So that's why I've created this DSA Dev Projects folder. I'll be pushing this folder to GitHub, and within this folder, I'll be creating multiple DSA plus full stack development projects. So if I create this folder, now inside this, because this is a full stack project, we need to have two more folders, which will be my client folder and my server folder. So first of all, let's focus on building the server first. Then we will create a client using our Next.js framework. So in this server, first of all, I'm going to create a file which will be called index.js, index.js file. Now this will be my main entry point for my server, where I'll be creating an Express application. I'll be switching on my server. I'll be having a few routes on which I'll be making an API call. Okay, and those routes will be taking a request and returning a response, like a normal server, like if you already know that, right? Now in this server folder itself, I'm going to have a folder which will be called as schemas. Now in this schema, I'm going to create a file which will be called tree.schema.js. So basically I'm creating a class where I'm going to define my binary tree, binary search tree, and I'll also be defining the functions for that binary search tree. Now inside that schema, let's create a class called tree.schema.js. Now in this file tree.schema.js, let's focus on creating a binary tree first of all. Now when I say binary tree, do understand that I mean a binary search tree, because that is only required for our purpose of file searching, right? So I'll create a class called binary tree. I'll be having a function, a few functions, but before creating a function or any function, I'll be creating a constructor. Now, as you know, constructor is the first function that runs automatically whenever you create an object of a class. This is a very basic OOP principle. Now, as you know that in a binary tree, you will be having a root node and you will be having children nodes, right? Left child and the right child. So as soon as I create an instance of my binary tree class, I want to define my root as null. So initially the root will be null. Root is equal to null. Now before we proceed with the binary tree class, I have to create a class, another class for my tree node, right? So node means entity, right? It can be a root entity, it can be a children entity, child entity, right? So I'm creating a node. So let's call it as class tree node. Now every node of my binary search tree is going to have certain values, right? So for this class also, let's define a constructor. Now this constructor is going to take key and is going to take value. Okay, so usually what happens in your binary search tree node, you have data and you have left child and the right child pointer, right? But over here, instead of defining data as a single entity, I'm defining two entities, key and value. And I'll be creating the search, I'll be having the search on this key entity, right? So whenever I have to go ahead and iterate through my binary search tree to find whether that file exists or not, I'll be taking the file name and I'll try to match it with the key. So key is going to basically store my file name. Okay. I'll also be telling you how to actually prevent the cases if two files are having the same name, but they are two different files, right? So for that, you can actually use UUIDs to replace the names with the unique ID for every file. But let's not get into that for now. Let's keep it simple. So key will be storing our image, the file name, and value will be storing some of the metadata of that file, like file size. It will also have the file path. Then it will have the file again name, right? So it is having the file metadata. So inside this constructor, I need to initialize some of my values. So this dot key will be the key that I've got as the parameter. Then this dot value will be the value which I've got as a parameter. I hope the font size is clearly visible. Then next thing is this dot left will be null, because initially whenever I define a node, it will not have any left child, or it will also not have any right child, right? So this dot right is equal to null. Okay, so this is my node class. Now every entity inside my binary tree is going to be a tree node. Even the root is going to be a tree node. Okay, so inside this binary tree class, let's create certain functions. So first of all, I'm going to write a function for inserting a new node to my binary tree, right? So first node, if you can answer, will definitely be the root node. Okay, so what I'm going to do, I'm going to define a function which will be called insert, right? And this insert function is going to take key and value, because these are the two things that I can expect from my client to pass it on to me, right? Through an API endpoint, right? Key and value means key means the file name and value means the metadata of that file. Okay, so constant new node, that means the node that I'm trying to insert in my binary search tree. Let's define it. So I'm basically going to create an object of my tree node class. Okay, so I'll be using new operator. So new keyword, and I'll be creating an object of my class tree node. So when I create an object of my class tree node, I need to pass on the parameters that my constructor expects, that is key and value. So I'll be passing whatever I'm getting from my client. So first of all, I need to figure out whether this is the first node that I'm trying to insert. So if my root is null, if this dot root is equal to null, that means my binary search tree is currently empty and I don't have any node in my binary search tree. That means even the root node is not yet added. So I need to define my root with the new node. So this is going to add the root of my binary search tree. But if the root already exists, that means my root is not equal to null, then I need to insert a new node to my binary search tree as either the left child or the right child of a respective node. Now I need to figure out of which node this will be a child of, right? So I will be creating a helper function just below my insert function. If it is getting confusing for you, that is totally fine. It can happen. But when I'll be revising this, all of your questions and doubts will be cleared, right? So just bear with me for next couple of minutes. So I'm going to create insert node helper. Okay. So let's define this function like this, insert node. So this is going to take a node, right, which is nothing but an object of my tree node class, insert node and new node. Okay. So this node means now I'm iterating, I'm traversing through my binary search tree, and for every node I'm figuring out whether this node should be the parent of my new node or not. Okay, so new node, that means the new node which we just created, right? So both of them I've passed to this function, and in this I need to figure out whether my new node dot key is less than my node dot key. If this is the case, then this new node can be the left child of my parent node, right? Right? Because in binary search tree, your left child should be smaller than the node, the parent node, and your right child should be greater than the parent node. This is the only funda that we are applying over here. So if my new node key is less than the parent node dot key, that means it is suitable as the left child of this node, right? So over here, what I can do, I also need to figure out if my left child, if my node, the parent node already does not have the left child or not. So if my node dot left is null, then and then only I can allot node dot left is equal to new node. But if the left child already exists, then I cannot add, right? I need to move on. Okay, so in the else part of this if, that if my left child already exists for my parent node, then I just have to use recursion, and then again, but this time the parent node will be the left child of my node, right? So node dot left, and the child that I'm trying to enter or insert into my binary search tree will remain the same, right? So what just happened? So over here, what we are trying to do, so in this insert node function, I'm just trying to use recursion over here. I took a parent node, I took a new node which I'm trying to insert, right? If my node dot key, if my new node dot key is less than the node dot key, right? That means it will go on the left child section, right? It will go in the left side direction. But if the node already has a left child, right, then I cannot insert this new node as the left child of this node, right? I have to move on, but I can only move on the left direction, right? I cannot move on the right direction because the right direction should always be greater than the parent node. Calling this insert node recursion function again, but this time the parent is my node dot left. Okay, great. Now handling this else. If my new node dot key is greater than the node dot key, then it should be a right child. But if the right child already exists, so again, if node dot right is null, that means no right child is there, then I can insert node dot right is equal to my new node. But if the right child exists, then I cannot insert my new node as the right child of this node. I just can call the recursive function again. This time the parent will become node dot right and child will again be the new node. Great. So this is my insert node function. And now over here, now coming back to the main insert function, if no root is there, then allocate new node as a root node. But if the root exists, then I just have to call the recursive function. I have to just I need to start entering into this recursion, this dot insert node, and the starting point will definitely be root, and your child that you're trying to enter or insert is new node, right? So what just happened? You started with a new node that you're trying to insert into a binary search tree. If the root is null, that means binary search tree has no child, no root, nothing, it is totally null, then you will allocate this new node as the root of your binary search tree. But if the root in the next part, when you're trying to create another file, you're trying to insert another file in your binary search tree, that time root will not be null. It will be having your first root, right? So you will be starting with the root, right, and enter into this recursion so that you can find out whether this file should be inserted as the left child of the root or right child of the root, right? But if your root already has a left child, over here I'm doing that, or a right child, then you cannot create or insert this new node as the left and right child of the root. You have to enter deeper, right? You have to go deeper into the binary search tree. You have to either go with the left side of the tree, or you have to either go with the right side of the tree. And that I can figure out using this property, because in binary search tree, even with the alphabetical characters or numeric characters, you have to follow the rule that left child of the binary search tree of the root should always be smaller than the root value, and right child of the root should always have the greater data or bigger data than the root node. So over here, as we are dealing with the strings, because file names will always be strings, here we are comparing the file names alphabetical wise. This we have already covered in the theory that we just saw just before this coding part, but this is just the implementation of how you insert a new node in your binary search tree. Okay. Now the next thing that we need to do is searching a node in the binary search tree. Okay. So for this also I'll be having a search function, right? So search, what you need to search? You need to search a key, because the user is going to enter the file name. Okay. So search key. Now for this search also, I'll be having a search node helper function. So again, we are going to use recursion. Okay. So let's define it like that, like this, search node, and this is going to take a node and a key. So for this node, we are trying to compare, we will be comparing the node value, that means the node data, with the key. That means node.key, if it is equal to key, that means the node is found, the file is found. But if not, you have to take decision whether you need to go in the left direction of the tree or you need to go in the right direction of the tree of this node, right? And how can you compare that? How can you decide that? If my node is null, that means there is no node existing, then you also can return null, right? This is an edge case. If my node is equal to key dot node, okay, node dot key, my mistake, node dot key, that means the node is found. This is the node which is the file, right? So you will be returning the value of this node that is having the metadata of the file, right? In the next case, if your key is less than the node dot key, that means the possibility is that the file can exist in the left direction of this node, left tree side of this node, right? Because the key is smaller. So smaller values will always be there on the left hand direction of a binary search tree, right? So I need to use recursion. So in this case, if my key is less than the node dot key, then I'm going to return this dot search node and go in the left direction of the node. So node dot left. So this will be your new node. You are just calling this function again, but you are interested in just the left direction, left side binary tree of your node. So node dot left. So just let me fix the brackets. Yes. In the else part, what will happen? You are just going to call the same recursive function, this dot search node, and you will be interested in the right side binary search tree, right children or the right child of this node, right? Because here in the else part, your key value is greater than the node key value. Okay. So node dot right comma key. Okay. So this is your search node helper function. Now over here, I'm just going to call return this dot search node function and pass the root, because root will be your entry point to start searching. Because if the root is found, root is equal to key, node dot key, that means root is having your file name. Okay. Pass the key, because we need to pass on this binary tree data to your client side also through an API endpoint response. So you might need another helper function will be to JSON, because you need to at the end convert this binary tree into a JSON format and give it to your client, right? So this is a very simple function. You just can write like this, return this dot root. So basically you are referring the root, and from that root every data will be taken, every node, whether it is left child or right child, will be taken, and in the form of a JSON it will be passed to the client through an API response. Okay, now you can export this binary tree class. So export default. So this ends our creation of a binary tree class, all the helper function where we are inserting a new node into the binary search tree, and we are also searching the binary search tree, because you will be doing only two things, whether you will be inserting a new file or you will be searching the file, right? That's it we are interested in. We are not interested in deleting a file and updating a file for now for this project. Okay, now let's start creating the index.js file where we are going to write down our server implementation. Now let's start creating the index.js file where our server implementation will be there. So first of all, I'm in my DSA dev projects folder. So let's go inside the BST file search. So cd bst file search, and now go inside your server folder. So cd server, and install certain packages. So npm install express. Okay, so it has also created package.json, right? So in this package.json, you can see all my dependencies are there. Okay, so the next thing is that I need to install is CORS. So npm install, so that I can access my server components, data, API endpoints through my client, so that the cross origin resource sharing can happen, right? You can study about CORS, or if you want me to create a video on CORS, let me know in the comment section. Okay, so npm install CORS. And another thing that we need is multer. So multer is actually used to upload files. So npm install multer. Perfect. So we have created our we have actually installed our three dependencies. Now go back to index.json, and in this start importing these packages that we just installed. So import express from express, then import CORS. The next thing is I also need to import my binary tree. So import binary tree from this location. And next thing that you need is another service. So like we created schemas folder in my server, I'm going to create one services folder. So we have only one service that we need to create, is upload file service. So I'm creating a file called upload.file.service.js. So in this file upload service, first of all, I'm going to import multer. So import multer from multer, right? And you need to create an object storage which will be using multer.diskStorage function. So multer.diskStorage, and in this you need to define two parameters. One is destination of your uploaded files. So destination. So for now I'm not using any database, because this video is actually focused on how to use a data structure in real life, in real full stack projects, rather than creating a complete full stack project, right? So my focus is on both teaching your data structure and actually creating a basic full stack project also. But in the further videos, if you want me to focus only on full stack projects or create an end-to-end tutorial, then I can also start implementing database connections and using MongoDBs, Redis, or some kind of storage buckets, so that it actually completes the loop. So I need to first of all know your interest, whether you are interested in such videos or not. So let me know in the comment section. So for now, instead of uploading the file on a S3 bucket, I'm going to store it in my local itself. So like I created services folder and schemas folder, in my server I'm going to create one uploads folder, which is going to hold my uploaded files. So the destination is going to be nothing but the uploads folder which I just created. And even if you were actually creating a service for uploading it to S3 bucket or any kind of object storage service, still you will be first of all uploading the file to your local server and then pushing it to the S3 bucket, right? Using multer if you're trying to upload. So destination is a function where you get a request you get a file that you just uploaded, and then there is one another parameter. So you can define it like this, null, and you can define the location of your uploads folder like this. So make sure the uploads empty folder is existing in your server folder. Then and then only this is going to work. Okay, I hope I'm clear. Now the next thing is, the next parameter that you need to define over here is the file name. So what file name you want to keep when your file is uploaded in the uploads folder. So for now, I'm going to define it like this. You get a request, you get a file, then again you get a error is null. So basically the first parameter is error. So if you want to handle the error, like if any exception comes or if any error occurs, then what do you want to do? You want to send a callback or whatever you want to do, you can do it over here. But now let's try to keep it simple. So error handling is null, and the file name will be file dot original name. So this original name from the client, I'm going to pass it as the key itself, right? So original name basically is it's a predefined property that we get in this multer file that is just uploaded, and whatever the file name was there in your local, the same name will be passed on as the original name, which is going to act as our key, right, when we are going to implement the search. So this is my service for uploading a file, very simple service. And next thing is, let's create an object which is called upload, and let's use multer now. So multer, and define the storage as the storage which you just created. Okay, now don't forget to export it. Export default upload. So you have created this. Now let's go inside index.js, and also you can import upload which you just created. Okay, now I need to initialize an variable. So constant app, which is nothing but a simple express application. Okay, so I'm now starting to create the server. Okay, now this app should use certain things. One, very important, CORS, so that CORS error does not come, right? Then next thing is JSON, express.json. These are two middlewares that we are using, express.json. Okay, now I'm going to create a tree which will be new binary tree. So as soon as my server class is initialized, whenever I switch on my server, an empty binary tree with null as the root will be initialized, right? First endpoint. So I'm currently also not structuring the code a lot because it's a very simple project, very simple server. But ideally you should have a different routes folder, repositories folder, controllers folder, services folder, right? So I'm not focusing on that for now. I'm just focusing on teaching you to handle like how you actually use like data structures in your full stack projects, right? Structuring and improving the code structure, you can do it on your own as you progress. So first endpoint will be an endpoint for uploading your file. So upload endpoint. So this will be a post call because you need to pass on some data in the body and in the file also. So let's slash upload be its endpoint. Now I'm going to use upload the multer object which we created, and it's a single file, upload.single, and let it be in a variable called file, right, which is already there in your call request. In the file, your file data will be there, and I'm going to get request and response. So my file will be in my request body, so request.file, right? So not the request body, but I mean to say in my request my file will be existing, right? So I have grabbed that file and stored it in a variable called file. Okay, if my file is not null, that means if my file is existing, then and then only I can move forward and I can return a response with a status. That means if my file does not exist, then you can return a response of status 400, or you can, 400 is a good one because it's a bad request, and you can pass the response in the JSON format with data will be success, will be false, and your message or error will be please pass the file. please pass the file. All good. Else, if my file was there, then I can go ahead and start inserting the file into my binary search tree. Okay, so for that I can use tree, which we just created, and use the insert function. So tree.insert, and the first parameter, as you can see, it is the key. So key will be my file name, and the next thing is your value. So value is nothing but your file metadata. So in the metadata I want to store path. So file path, it is actually defined as path itself. So file.path, size, what is the size of my file that I just uploaded? So that is actually file.size, and next is your MIME type, like it is a PNG or it's a JPG or it's a PDF, any file is allowed, right? So MIME type, and over here I need to say file.MIME type, right? So you would have seen like content/JSON or image/PNG, image/JPG, like like these are called the MIME types. Okay, so let's save this. So this is your insert function, and now you can return a response. So constant response will be I'm going to pass success as true, and I'm going to pass a message which will be called as file uploaded, and the next thing will be data, which will be tree, and my file as my file. And over here I can use tree.toJSON, which we created, right? So tree.toJSON, and file is a file which is just uploaded. So this is just a response that I want to send it to the user that you just uploaded this file. This is now my updated tree, and this is the message, and success is true, right? Now I can return response.json, and you can pass your response. Perfect. So this is your endpoint for uploading your new file. Okay, last thing that is to be done in our server, then our server will be end-to-end completed and it will be ready to accept request. The last thing that I need to do is handle another endpoint that is for searching a file, right? This will be a get, because you need to get some data. The endpoint will be search, right? And you will be getting a request, right? And in this, the key the user is going to pass in the query, so response.query.key, okay, and the result that you're going to get is tree.search, and pass the key. Okay, so if your result exists, that means if you found the file, so if the result exists, then you can return response.json, your success will be true, and your data will be the result which you just found. Okay, perfect. If your result is not found, right, if the file does not exist, if you are just trying to search a random thing, then also you need to return a JSON, but this time your success will be false and your message will be file not found. Don't worry, you're going to get all of this code for free. You should not worry about that, right? But I'll highly recommend that you code along with me. That's the only way you can learn programming. Okay, code along. Don't wait and don't just blindly copy the code, right? Because if you're just trying to blindly copy the code, then nobody's going to hire you. They will hire ChatGPT, right? So I think this is done. Now one more endpoint I can create, that is just to show the tree, right? Because I need to also visualize the tree in my client, right? So app.get, this is a very simple endpoint, that is show tree. Okay, and this again takes a request, and this just returns with success as true and data as tree.toJSON. Now let's switch on the server. Let's put a semicolon, and app.listen, let's make it listen on port 3001. And as soon as my server is on, let's console running on port 3001. Okay, that's it. We are done. Our server is ready to accept calls. Okay, now let's make some dummy calls so that we are sure whether our server is working fine, and then we can go ahead and create a Next.js app. But before that, you can see 826 changes are there in my Git. So what you can do, it is actually trying to upload your node modules also, right? So what you can do, in my BST file search, I'm going to create a file called .gitignore. Okay, you can see, because I don't want to pass node modules to my Git. Anyone can take a pull and run npm install to get this node modules folder in their system. Okay, perfect. So that's it. Now let's go ahead and make some API calls to test our server. Now for testing this, we definitely need some files that we can upload. Now yes, I can also use some 4 or 5 files that I already have, but let's say you want to try with, let's say, 100 files, and you want to compare the time of searching a file, right? So for that, I'm going to show a very simple Python script that will automatically generate 100 random files for you with random textual data. Okay, so that you don't have to worry about bringing the files that you can test with. So I have created a new folder called dummy files in my desktop, and over here I'm going to write a script.py, right? Very simple script. Even if you don't know Python, that is totally fine, right? So first of all, I'm going to import and this script I'll also provide you in my description. If you directly want to use it, you can directly use it. Import OS, that is operating system, so that I can actually get the reference of this location where I'm going to put the files. Okay, then import random, then you can import string. Okay, then write a function random string. So this I am generating for generating the file names and also for generating the random textual data. Okay, then you can define some length. Okay, then return dot random dot choice string dot ASCII lowercase. Okay, for I in range length. Now just in a minute I'll be showing you what is the meaning of this simple function. Okay, let me close this. Another function that is for generating the random data, and this also takes length, and for this you can say return dot join string dot ASCII lowercase plus string dot ASCII uppercase plus string dot digits. So basically this function is going to generate random data for my text files. String dot digits. How many like how much you want to create? So for I in range length, whatever length I'm going to get as the parameter. Okay, now write a function to generate the files. For I in range 100, so I'm going to create 100 files. For I in range 100, file name. So file name, let's generate it using the random string generator. So file name is equal to random string, and let's keep it 10. So a name of 10 characters plus .txt. So that extension is also there. Okay, so this is my file name. Now open this file. So with open file name and put random data inside this file. So file name, how you want to open this file? With permission of writing data to this file. So w, okay, as f. So open this file and store it in like a variable called f. F dot write. So f dot random data with random number of characters or random number of data, like random characters inside this file. So random.randint 1 to 1000. So pick any number between 1 to 1000, and of those many characters you put it in the file. Okay, now call the generate file. Let's run this script. So there is an issue. Okay, let's remove this. Yeah, now no issue is there. Let's run this and let's see if we get 100 files over here. You can see 100 files are generated. Now you can also see these 100 files in my file explorer, right? So even if you are on Windows or Linux, this code is going to work without any issue. Okay, so this has generated random files which I can upload to my binary search tree, and any file that is there I can also search in that binary search tree. Okay, now let's go to Thunder Client. So Thunder Client is just a VS Code extension that I can use for making API calls within your VS Code. So I'm going to run my server. So for running my server, what I need to do is I need to just write node index.js. Okay, so there is an issue. Let's try to fix it. Import express from express. What is the issue? Cannot use import statements outside a module. Okay, so let's go to index.js. What is the issue over here? So import express.js. I think this should solve it. Okay, so warning to load an ES module, type module. I think this is the issue. So let's go to package.json, and over here you need to just define type, and this type will be module. Save it and again hit node index.js. So there is another issue. Let's try to fix this. Schema.js. Yes, so this is again ES linting issue. So over here service.js, and this will be schema.js. So I think this should fix it. Yes, you can see backend running on port 3001. Now let's go to Thunder Client, create a new request, and over here write down your endpoint HTTP localhost. We are running on port 3001. So 3001 slash index.js. You can see search. Let's try to search a file first. So if you go back to Thunder Client and in your new request slash search. Now in the search, you need to define the key in your query itself, and it's a get call. So in my query, let's try to search whether this file exists in my binary search tree or not. So I'm just going to copy the file name. So I'll just go and click on rename, copy, and I'll go over here, query is equal to this .txt. I'm just trying to search whether this file exists in my binary search tree or not. Okay, so let's see what we get. So if I hit it, you can see file not found. Of course, file is not there, right? Now let's try to upload the file. So I'll just save this API call. I'll just save this API call, and I'll have a new request which will be having the same base end URL. So I'll just go over here. I'll make it a post call. I'll save it. And you can see in my index.js, for uploading a file, I just need to hit /upload. So /upload, and all I need to do is, if you can see in my index.js, all I need to do is upload a file in this request. So I'll just go to form, and you can see there is files checkbox. So just switch it on, and you can see you have got a place where you can upload a file. So call it as a file and choose a file. So go to your desktop, then you can go to dummy files, and in this you can upload any file, right? So let's say I upload this file, open it, and let's hit send. So there is an issue. Let's try to fix it. I think it is because of this. No, this is not the issue. Multipart file final. Okay, the issue is file sending feature is only available in the paid version. So I think we cannot use it. You cannot use a Thunder Client. So let's try to use Postman. So now you can see that I'm on Postman, and make sure that if you're using localhost endpoint, as we are also using localhost, you need to have Postman downloaded in your system locally. You cannot use the Postman web. Okay, so I'll click on new, I'll click on an HTTP request, I'll paste the endpoint and I'll make it a post call. Let me increase the font size and I'll click on body, form data, key will be file, and click on file, select a file from local machine and go to dummy files, select first file and click on send. So you can see we have got file uploaded and we have also got the data. So this is the data that we just uploaded. This is the metadata of our file. This is the key, that means this is the text. This is the value, path, upload slash this, size is 336, MIME type is text slash plain because this is a text file, not an image, not a PDF, right? And you can see this is some information about our file because this is the response that we gave from our server. Now in my server, if you go and click on this uploads folder, you can see the file is uploaded in my local, in my server itself. It is staying in my server, right? It is not going to any storage bucket yet. Okay, perfect. So let's upload 2-3 more files so that I can actually visualize my binary tree. Okay, so okay, let's remove this and new file. Let's select the second file. Let's hit send. Okay, done. Let's remove this and this time let's select a file with a different name, starting alphabet. So let's start with C. Open. So you can understand what is going to happen. C, the file which has file name starting with C will always be on the right hand side of the binary tree. That we can visualize right now. Just give me a minute. Okay, done. Now let's select one more with B. Okay, so this is B. So this should be on, this will be definitely be on the right hand side of your tree, but will be on the left hand side of your C. Okay, by B and C I just mean the file name starting alphabet, right? So let's hit send and now let's upload one more, the last one with D. Okay, yeah, D. Okay, open, send. Perfect, awesome. So now we have uploaded the file. Now let's try to search the file. You can see all the files are over here. Okay, now let's try to search a file. Let's search this file itself. Okay, rename, copy. Okay, and let's try to let's save this endpoint. Now in this collection itself, I'm going to create another endpoint, add a request that will be for searching, search file. Okay, and this will have the same endpoint but with search, and query will be having the key, key is equal to this file name. Okay, perfect. Let's save it and hit send. File not found. Okay, what is the issue? This file should have been existing though. Okay, so this is not working. So let's try to hit show tree so that we can actually see our tree. So let's add another request and let's call it show tree. Okay, so this is the tree. In the tree, I have a root node with my file starting with A because this is the first file that I uploaded. The left child of this root node is null. Okay, why? Because the next file is AQ. So AQ will always be on the right hand side of AE, right? So it has a right child with AQ. Okay, so this is fine. Now the left child of AQ is null and right child is this CMA. Why? Because C is going to definitely be on the right hand side because it is alphabetically greater than AQ. So then we again have a right child CMA. Then this right child does have a left child because BE will always be on the left hand side, and that's why then we have a right child also because DMK will always be on the right hand side of CMAL, right? So that's why this file node CMAL ZNCINH is having both a left child and a right child, right? Why? Because BE will always be on the left hand side and DMK will always be on the right hand side, right? And again, if we go inside, this file node is not having any left child and right child because this is a leaf node. This was the last file. And DMK file is also not having any left child and right child because this is again a leaf node. It was the last file in this tree part. Okay, so tree is great. Tree looks good to me. We also have the sizes, we have the MIME types, we have the paths. So this looks good. Why did the search not working? Let's try to search the root node itself. Let's try to search this one. Let's hit send. Okay, file search is not working at all. I think we are missing something. Let's close the server. So I have found the issue. So we did a very silly mistake. The issue was when we uploaded the files, after that we had switched off the server, and then we switched on the server. Because of that, if you see, when you switch on the server again, then again your tree is initialized, right? So if you go to index.js, you can see again we initialize the tree. So when we did that, our tree was actually again empty. So you cannot switch off the server once you have uploaded the files. You have to keep it on so that this tree is maintained. Okay, so this was the issue. So now I have again uploaded all my files. As you can see, all the files are again uploaded, and now I have not switched off my server. And now when I hit search key with this file name, you can see the success is true and I got the data back. Node.value, path is there, size is there, and MIME type is there. If you want, you can try with another file. So if I try with this file name, copy this and go back over here, paste it and hit send. So you can see again your data, the data is, we are receiving the data back. Okay, so that means our APIs are working fine, search is working. We saw that visualizing the tree is also working fine, and uploading is also working fine. Now let's go ahead and start creating the client side using Next.js. Okay, so now let's go ahead and create a Next.js app. And I don't know how to create a Next.js app. So let's go ahead on the internet and search the command for it. Command to start a new Next.js web app. Okay, so create a Next.js app and you will find a command that is there to create a new Next.js app. I think this is still complex one. I'm just searching for the simplest command. npx create next app and the name of the application. Yes, this is it. npx create. So let's create a new terminal, and this is again in DSA dev project, so that is good. I just need to go inside bst file search, and now npx create, the command is npx create next app, npx create next app. Let's do this much. Need to install the following packages. Yes, so why? What is the name of your project? So I'm going to name my project as client. Okay, so that it creates a client folder inside my bst file search. Okay, I would like to use TypeScript. Yes, I would like to use TypeScript. Would you like to use ESLint? Yes. Tailwind CSS? Yes, of course. And yes, inside source directory. App router? Yes. TurboPack? No. And import alias? No. So basically I have kept all the settings as default. So you can see I have my client folder inside my bst file search, and over here you can see it has all the files. It has my package.json, which has all the required dependencies, and by just running npm run dev I can start my next web application. Okay, so let it complete and then I'll hit npm run dev. Okay, so that's done. So let's hit npm run dev. Okay, npm run dev. What is the issue? Okay, I need to go inside client, so cd client and then npm run dev. Okay, so it should start my web application. So it is running on localhost 3000. So let's go on localhost 3000. You can see my Next.js web application is now live. Okay, so this is all good, and now we need to start creating the UI for this. So let's go ahead and create some of the files and remove some of the files. So basically if you go inside the source, you have this app and you have this page.tsx which has all that code. So I'm just going to remove this code and I'm going to start writing it from the scratch. So I'm going to create a React component that I can create using RAFCE. So you just have to install your ES6 extension, and then you can also just type RAFCE, hit enter, and it is going to create a simple React component. So this is my home component, so I'm going to call it as home. Okay, home. And over here in my export default apps, yeah, this is, I think, this home export default home, that is also correct. So over here, if I just hit Command S, and you can see my home, so the content is changing. That is good. Now inside this return component system, I need to start designing my complete page. Okay, so what I'm going to do is I'm going to create a div. That is totally fine. This is good. And inside this div, I am going to, let's remove this. The first thing that I'm going to write inside this is my parent div is an h1 tag. That is the heading of my web application. That is file search. And using tailwind.css, I can give this text some properties. So let's define class name. Text should be large, so text to Excel, and it should be bold, so font bold. Then text should be at the center, so text dash center, and it should be gray 100, so gray 800, so that it should be dark, because I'm going to make my web application in white theme. So text dash gray 800, and margin from the bottom will be 6. Okay, now let's also give some properties to our main div tag. So let's define class name, and let's give it maximum width on the larger screen, and let's give it some margin on the x, that is x-axis, that means your horizontal axis, as auto. And let's give it some padding 6. Let's give it some margin from the top so that it does not touch the roof of my screen, and I think this is good. And let's also give it some background color as BG gray, slightly gray, so dash 100. And let's give it some rounded border so that it looks clean, rounded large, and I think this is good. Font, we can give it like sans font. Okay, so I think this is good. If you just hit enter, so you can see it looks like this. So this is also good, not a problem, but I would like to make it in white theme. So just going global.css, and for now just comment this dark theme part, and you can see it is now creating it in white theme. Okay, so this is good. If you want, you can create it in dark theme also. I'm not against dark themes. Okay, now let's create some sections. So just below this heading, I need to create a section. So I'll create another section which will be called as file search. Okay, so I'm going to create a new div tag for this, and this div tag will have some properties of margin from the bottom as 8. So I think this is good. And now let's have another heading, smaller heading, h2, that will say search for a file, and let's give it some properties. Class name, text large, and it should be font will be semi bold, and let's give it some color, so text gray 700, and margin from the bottom as 4. Let's format it, and let's see, yeah, search for a file. This is good. Now just below that, I want an input field. So this input field will be my text field where I'm going to enter the key of my file. Okay, so the value, I'm going to define one variable at the top, which will be query, whatever I'm going to type over here, query, and on change, I need to set the query. So whatever I'm typing, it should set the query as soon as I change the text in it. Okay, so set query, and it should be e.target.value. So whatever I typed, it is going to set it to the query variable using my set query function. Okay, and I also need to have a placeholder that is just like a hint, and to give it some beauty, I'm going to define some class name. So w will be full, whatever it has available with it. padding in the x horizontal direction as 4, padding in the vertical direction as 2, and let's give it some border. Let's give the color border gray. I think 300 will look good. Then rounded large so that it looks cleaner, and focus will be like when I click on it, that is called the focused state, right? So let's make it none, and focus you are going to see just in a few minutes whatever I'm doing right now. Focus it should be like this, focus ring 2, and focus should be focus ring, I think let's give it some color. I think blue will look good. Ring blue 400. Okay, so over here now I have defined my input field. I can also just below this I can define a button that will say go ahead and search the binary tree. Okay, so let's create a button, and in this button I'm going to have a text called search, right? So to this button also we need to define some function that runs whenever I hit this button. So that function will be called as handle search. Okay, let's make it beautiful. Margin from the top will be 4, width whatever is visible. Let's give it some background color, background blue 500 will look good, and let's make the color of the text as white, so text white, padding y2, then I think rounded with the same LG so that everything looks similar. And when I hover over this button, I need to give it some effect. So background blue, let's make it 600, and this should look good. And I think focus is important, so focus outline none. I think this is good, and let's also make it focus when I hover over it, or when this button is in focus, then let's give it some ring, and the ring let it be again in the blue color. So let's copy this and let's paste it over here. Now let's just define the function so that we can start so that we can actually render it and see the UI. So at the top, export default function home. So instead of just defining it as a constant home, what we can do is we can define it like this: export default function home. Okay, and this will be like a function home, and I don't think this is needed now. Yes, this is all looking good now. So inside this I'm going to define some variables. First one will be query, so whatever I'm going to type right now, function use state hook we are going to use. You need to have some basic knowledge of Next.js, or even React.js is okay. Use state. So let's import this use state, and next is basically I think this is good for now. This is good. We just need to create a handle search function. So constant yeah, for now I think let's make it try catch, and if anything goes wrong, let's log the error, console.log error. I think this is okay for now. Format it, save it, and we need to use client over here. Save it. This should work. Yes, you can see file search and upload system, and you can see whenever I hover over it, you can see that the hover effect is there, and you can see the border is there, the ring is there, focus ring is there, border is there, right? So everything is working fine, and whenever I type anything, it must be setting the query, right? Like whatever I'm typing right now, it is actually setting the query with that value that I just wrote. Okay, so I think this is good. This is good, but we need to do a lot of things other than this. This is like a very simple thing. The next thing that we need to do is we are going to write the handle search and handle upload, not a problem. But just before that, let's complete the UI, because over here I'm going to type the file name that I want to search, But one more thing we need to create just below this is a place where I can upload new files. Okay, so let's create that. Okay, let's go over here. After the button, I think this button is looking good now. And okay, I need to create one more thing. But let's create it afterwards. So just below this div, I'm going to create file upload section. So this was one section where I was searching the file. Now there is another section which is file upload section. So file upload section will again be a div, new div, right? So let's define some class name to it with margin bottom 8, right? Now inside this div, there will be a component that is will be a button where I can pick a new file and I can upload it. So again, let's put a heading. I think we can copy the same heading from here, right? So let's copy and paste it, and let's say upload file. You can see upload file is over here. Okay. Now again, this is going to be an input, but this time the input will not be text, it will be file, so that I can start picking it up. You can see the upload button is over here. Okay, so input type will be file, and again on changed. What happens when I pick a new file? So again, you will see whatever you have picked, set file. Set file will be e.target.value. So whichever file you pick, it will be not value, it will be files. Search.e.target.files. If you have picked multiple files, then it is going to take your first file only, because at a time we are allowing only one file to be uploaded. So pick it at 0, and if it is null, then you can call it as null. Okay, now let's give it some designing, some beauty. So class name, W will be full again. Then you can make this button as green 500, and text will definitely be white, because on green white text will look good, and padding Y will be 2. Rounded again, we are trying to create the elements with the same design schema so that they should look similar, right? And on the hover, I'm going to give it some effect. So hover, BG green, will change it to 600. Okay. Again, focus outline, I guess that we can pick it from here. Focus outline, this same thing we can copy and paste it over here. But this time this will be green 400. Okay. Okay. Now let's create a function at the top which is going to set my file. Okay. So for that, I'm going to go ahead at the top, and over here just below query, I'm going to say constant file set file is equal to use state, but this time the type will be okay, so null, and you can by default you can initialize it with null. You won't be having any file picked up. Okay, so this is good. You can see this looks okay, so this looks bad actually. This looks bad. So what we can do is we need this button to be outside of choose file. Like we need the choose file button outside of that green color thing. So margin from the bottom will be 4, W will be full, padding in the horizontal axis will be 4, and on the vertical will be 2. Then let's give it some border, and then let's give it border, colored border, basically border gray 300, and let's make it rounded large. I think this is good. Yeah, I think this is actually good enough. We can define a variable at the top, so you have to define it like this. Last time it was query and it was of type string, but this is set file and it will be of type file, and by default it will be null. Let's format it, and just below this input I also need a button that is going to handle the upload. So I'm going to define a button. This button is going to be on click of this button, I'll have handle upload. So again, I'm going to define this function at the top, and let's give it some class name. So W will be full again, and background green 400, and text will definitely be white, and padding from the Y direction to be 2, rounded again LG. Yeah, let's give it some hover effect, and I think that should be it. Hover BG green 600. I think this is good. Let's handle the upload at the top. So let's define a function just below this, constant handle upload. Then you can set an alert box. Please upload a file. But else, what you need to do, you can return. Okay, so okay, just like this. And if your file is not null, that means you really uploaded and uploaded a file, then you can create a form data, just like the postman we did. We uploaded the file through a form. So new, right, and over here form data dot append dot, you need to append it like this, file, just like the postman. You can see file. Okay, great. Now you will make the API call. Okay, that let's do it in a bit. Okay, we did not write anything inside the button. This will be called as upload. Okay, this looks good. Okay, so we have a simple UI where you can search a file and you can also upload a file. Okay, you can pick a file also, right? You can see, you can pick a file. This looks good. Great. So the next thing that we need to do is we need to write the API calls for searching, uploading, loading, because it will take some time to upload. So loading effect. And if search is not found, that means if the query is not found in my system, then it should show something over here that the file does not exist, right? So let's write down the API calls over here. So first of all, let's complete the API call for uploading the file itself so that we can test whether the uploading is working fine or not. Okay. So before that, I'm also going to define some more variables over here. So query is defined, file is defined. Let's define the result, because I'm going to get some result from my API when I hit the right. So set result is my hook, and it will be search result. So this is a interface or a type that I'm going to define right now, and search result can be null also, and by default it will be null only. So this is like one thing. Then next thing is upload status, whether the file is uploaded successfully or not. So upload status, set upload status, and let's use state hook, use state, and again I'm going to define a type upload status. It can be null also, and by default it will be null only. Now let's define these two types, set result and upload status, right? So these will be interfaces. So I'm going to define interface, my mistake, interface search result, and in this you will have success. So you can get it from your postman call itself. So you see success, and after that what I get is I get a message that is, so this, yeah, message, this will be string, and the next thing that you get is data. So data will be, then you get the path of your uploaded file, not the uploaded file, basically the search result. You get the path and you get the size. So if you see your postman search a file, you get success, then you get data, you get path, size. MIME type we are not interested. Okay, you get path, you get size, because these can be null actually, right, if the search result is empty. So this is my search result. The next thing that I need to define is my interface for upload status. So you will get success, this will be boolean, and you will get a message that will be string, that you can see from here. Upload, you get success, you get message, these two. Okay, perfect. So this is done. Now let's write down the API calls for handle upload and search, handle search. Okay, so let's write down the API call for handle search itself, because that one is really simple. In the try, I'm going to write result, constant result is equal to await, use fetch, that is provided in the Next.js itself, and define your endpoint. So as you know, my endpoint is HTTP localhost 3001 localhost 3001 slash search question mark query dollar, and you put your query. And this will not be query, this will be key, because I'll just show right now. If you see in my search file, you can see this is the key. So that same key we need to define over here. Now I'm going to get some data from my API call. Let's call it as constant data, and this should be of type search result, right? Await response, response dot JSON. And now you can set your result, whatever result you got, set result, and you can pass your data. And if your result is null, that means it went into an error, then your set result will be, this is going to handle your search. Now once your search is successful, you need to write down over here that your file is found and this is the location of your file. Okay, so we'll do it just in a minute. Let's complete the handle upload function also. So over here I defined my form data, and now let's make the API call. So let's keep it in try catch, because this can go wrong. So constant result is equal to await fetch again, and inside this fetch again define your HTTP localhost 3001 slash upload, and in this define some body, and your method is going to be, and your body will be form data. That's it. This is going to upload your file. Okay, so if my file is uploaded successfully, then I'm going to get data as upload status is equal to await response dot JSON, and then you can set upload status with data. And you can also set the file as null, because now you should be set for uploading a new file. And for catch, let's log the error, console.log the error, and set upload status as null and set file null, and this should be null. Perfect. So we are ready with upload status also. That means your code is ready to upload a file also. Now we need to do a few things. That is, when your search is done, that means you have got a result, right? So just below this search button, you need to define another component, right? And that is a conditional component, right? So that's why I'm writing down these curly brackets, because I need to write a condition if I have a result available with me, right? So if result exists, and basically if my result exists, then you need to show this component, right? So put circle brackets and define a div, right? So in this div, basically what I'm going to have is, first let's give it some beauty. So this is going to be gray colored box. Class name, it will have some margin from the top, margin top 6, adding 4, let's make it white itself, so white, and let's give it some border, right? Let's give it some border, and border color is important so that it is visible, 200, and again rounded, because we need to follow the design scheme. Okay, div, and inside this div, inside this div, I need to start putting, so I need to create the condition also again in this, right? So where am I? I'm just getting confused. This is my division tag, and okay, this looks good. So in this division, within this division, I need to write down another condition if the result is successful, because if the result is successful, then only I'll say heading, basically a division, and inside this division I'll say a heading that will say file found. And if your file is found, then you are going to show the metadata of that file. So P, you will show result.data path. Okay, so this, and just below this you will have another P that is going to show the size. So this is one homework I'm giving right now. The size should be always in KBs or MBs, right? That's up to you. So you have to decide that this code. Okay, how will you do it? Okay, so one mistake we have done, I think we forgot to close the division. This div is getting closed, this division is also getting closed. I think there is one messed up thing that we have done. Let's remove this for now. Okay, so within this div we need to put that code. Okay, so let's put this. Okay, so this gets closed over here, result.success. Okay, I think we also need to write down another condition. File, basically file not found, right? Or the message whatever I get from the backend, that also I can put. So P and whatever data I get from my dot message, whatever I get from my backend, I can put it over here. Basically we need to design these headings and text also. So let's do that. So let's give it a class name, and the class name will be text green. Let's make it green because this is successful. Let's give it 600 color, and font will be semi bold. This is good. Let's make the design of these two as text gray 700. I think this is good. I think we also should say where what is this? Actually this is a path, right? So let's define a strong tag so that it is a little bit bolder. Strong tag, and in the strong tag I'll say path like this. Similarly I'll put the same thing over here, and just before this I'll put it like this, and this will be my size. I think we are done. I think we are done with everything. We have done everything right now. Okay, let's do it. Let's try to run our system and see if it is working. So I am going to inspect my element so that I can see the network calls. I'll go to network. I'll clean everything up. Okay, now I'm going to search for a file. First of all, let's search for a file. Let's see if my file exists. So whatever file that exists in my binary search tree, let's try to search that first. So in my server, this file exists. So I'll rename, copy this, and I'm going to put it over here, .txt, and if I try to search it, you can see my file is found. This is the size and this is the location, right? Now if I try to search another file, v, you see, okay, there is an issue. So if we got this null, we are not able to see the error message. What is the issue? So if I go to my path, result, so if my result is there, then only it is going to show that. Okay, so what we can do is when we are handling the search, there itself we need to define, instead of defining it as null over here, we need to define it like this. You define a success as false, and you define the message as file not found or error searching file. Okay, and for this division, you can also define class name text red 500. Okay, let's do it. Yes, you can see error searching file. Now if I try to upload a file, let's upload this ttsv1, upload. Okay, so it should also say a file uploaded successfully. So let's handle that condition also. So at the bottom, just below this button, we can have another condition. So if my upload status exists, that means upload was successful, then I'm going to have another division. So this division will have a margin from the top as 6, padding will be 4 from all sides, and background will be white. Let's give it some border, and let's give the color to my border gray 200. Okay, this is okay, and let's again give rounded as LG. Okay, so now again a condition inside this, a condition, if my upload status dot success, so if my upload was really successful, then I'm going to define, yeah, I think this is okay, upload status is, I think this is not right, this is not right. Yeah, because this is not right. Upload status dot success. Oh, okay, this is the issue, because I was trying to create the condition. I have to write the condition inside my div. Yes, now it is perfectly right. So if this happens and if my upload is successful, then I'll have a p tag which says whatever I got from my uploaded status dot message, which will be file uploaded successfully. And if this is wrong, or if the file was not successful, then also I'll say the same thing, uploaded status dot message, but they will have different designs. Okay, so this will be class name text green 600, and this one will have a class name with text red 500. You can see file uploaded, perfect. So I think this is working fine. Now let's try to search the file again. Okay, let's try to search the file again. Let's search a file which we just uploaded. So let's try to copy this. Okay, this is not getting copied, but let's try to copy the name from here. So you can see the file is uploaded. So let's try to copy it from here and let's paste it over here. .txt search, you can see the file is found. Perfect. So our binary search tree based file searching system is working fabulously. Okay, no issue, no doubt, like no blocker, nothing. We have solved all the bugs and this is working great. Okay, so this is how you create a file searching system with the time complexity of big O of log n. If you would have used a list and you would have stored all of these files, then you will be having the time complexity of big O of n, which is definitely worse than the binary search tree. Okay, so this is how you have created a system. Now let's create a page, localhost 3000/show tree, that is going to show my binary tree. Let's do that. Now we have written the code for uploading a new file, searching a file. Now we need to write a new page in our Next.js client where we can actually visualize the binary tree. Definitely, I have not written any chart code where you can actually see the binary tree chart. That is actually your homework, where you have to research about like d3.js library or any other visualization libraries where you can actually visualize the chart of binary search tree. But I am going to show you the chart on this Next.js web app page that can actually help you visualize the binary search tree. Then we will also visualize that binary search tree of our 6 nodes, because you can see that we have 6 files in our uploads folder on a blackboard. Okay, so first of all, go to your client again, in the app folder, in the source, in the app folder, create a folder called view tree, so that I get a route/view tree. Okay, now in this, create a file called page.tsx. So in this, create a React component which is called, okay, so in this, if you hit enter and if you go to view tree route, view dash tree, you can see view tree is here. So that means our route is working fine. Okay, so in this div, before this div, I'm also going to define an interface which is going to basically show my node. So that will have all the properties that my tree node is having in my backend. So I'll have a key which is a string, I'll have a value which is of type any, then I'm having a left node which is again of type node itself, or it can be null. I'm having a right child which is of type node, or it can be null itself. Okay, then after that I'm going to have a variable in my view tree which will be constant tree data. Initially this tree data is going to be null because I don't have any node. As soon as the app page loads, then I'm going to make an API call and initialize my tree data. use state. Great. Now I'm going to define use effect, because as soon as the app page loads, I need to make an API call. Okay. Constant fetch tree is equal to, this is a function that I'm writing, async function, which will have a try catch block. Now in the try, I'm going to write down constant response await http localhost 3001 / show tree. You remember this route, right? Then we have constant data is equal to await response.json. Perfect. Now you can set the tree data. Set tree data at data, because if you see my show data response, my data is inside the data key. Okay, so that is why like this. And if something goes wrong, then I'm just going to log my error. Perfect. Now in the div, but before that, let's call this fetch tree. So just this I'm going to call fetch tree, and default it can be like this. Perfect. Now in the div, I'm going to have some styling of this div, but before that I'm also going to write down another function that is going to render my tree, because I'm going to get a JSON, right? But I need to see some visualization that looks similar to a tree. So constant render tree, and this takes a node, can be null also. Then I can say return itself, which says null. You can definitely improve it. Otherwise I can return view tree, but instead of that I'll return this div. Let's give it some styling. Instead of tailwind, let's use style. You will have margin left 20 pixels. Then let's use border left 1 pixel, and let's use dashed gray. I'll just show you in a minute why I'm doing like this. Padding left. You'll just visualize in just 1 minute that what is the significance of all of this styling that I'm doing right now. Okay, so the styling is done, and now we can start with the first thing, that is defining your node data, because whatever nodes I've got from my backend in the JSON, I need to start showcasing those nodes. Okay, so so in this div I'll have a strong tag. So in the strong tag, the value will be node.key. So this node is actually coming from the top. So that's why ideally this return should be over here if node is yes, else this. Okay, so if my node is not there, then null, but otherwise this is the thing that I need to do. So I need to define the key of my node, right? Because that will be the first because this is the root and this is the first node of my tree, and this is the strong tag. That means this is my key dot stringify, json dot stringify node.value. Why? Because if you see, this is my key, but the value is again JSON, so I need to handle it like this. So node.value, so that I can visualize that. And as soon as this is done, this is my division tag for my node, and then I'll define my left nodes and my right nodes. Okay, so again define a div. This div is again going to have a strong, and this is going to say this is going to say left node and render tree. So I'm going to remove this. So this is going to be strong left, strong this. I'm going to call the recursive function. So render and render tree function takes a node. So this time I'm going to pass node.left. So node.left, and this will be inside the curly brackets. Okay, perfect. Now similarly, take a div and paste it like this, and this time this is going to be right, and this will be node.right. Okay, great. So this is my render tree function, which will work without any issue. And the next thing that I need to do is I need to define the return of my view tree. So return a division. So in this div, I'm going to define a head which will say binary view, right? Binary tree view. And just below this, I'm going to define then render the tree, tree data. So starting node will be my root itself, and if it does not exist, then define a paragraph that is p tag, and in this say loading tree. I think we are done. So use effect. So we need to make it a client rendered component. So use client, and yes, so you can see your let's give it some heading. Will have class name, which will have this is fine. So you can see this is my first node. Okay, so this node, which is my parent node, which is also called as a root, this is the key for that, and this is the value for that. Now this has no left child, so that's why left is null. Then my root has a right child. Why? Because AQ occurs after AE alphabetically, right? So it has a right child. This is the node data, the key and the value. Then my right child, which is AQ, has no left child. So again, this is left. This is null. This has a right child, but so this is my right child. Okay, so it has a left child, it has a right child. Okay, but these nodes are my leaf nodes. This is a leaf node, right? Because it does not have any left child, does not have any right child. But DMK has no left child, but it does have a right child because we added another file at the end which starts from TTS. So TTS is going to occur at the end. So that's why it occurs after DMK. It does not have a left and right child. So this is also a leaf node. Now let's try to visualize this tree on Blackboard. So let's start from a root node which starts from AE, right? So I'm not writing the complete name. Let's write down the first two characters, because that are enough to decide whether it's a left child or it's a right child. So AE, this was the first node that I uploaded. Now after that, I uploaded a file which started from AQ. Now that cannot be my left child because AQ occurs after AE. So that has to be a right child, right? So over here, I'm going to have AQ, right? So this was my next node of my binary search tree. Now after that, now this does not have any left child, so this is cross. Okay, but this is my right child, and this was my root. Okay, so after that you can see that I uploaded a file which started from name CMA. Okay, so that cannot be a left child because CM, that is C, occurs after A. So this is cross, but this is going to be a right child which starts from CM. Okay, now CMAL, after that I uploaded a file which started from BE. Now BE cannot be a right child because B occurs before C. So this has to be a left child. So over here I'll say BE. So it cannot be a right child, but it is a left child. Okay, great. Now BE, after that, now CM also has a right child, right? Because after that I also uploaded DMK file, right? So DMK, that is D, occurs just after C. So that can be a right child. So I'll remove this and I'll add a child to it, which is DM. Okay, great. Now after that, you can see that I uploaded a file which is starting from TTS. Now that cannot be a left child of DMK because TT occurs after DM. So that has to be a right child. So after that I added TT, and it cannot have a left child, right? So this is how our binary tree is looking currently. And my leaf nodes, if we have to detect our leaf node, this is my first leaf node, this is my second leaf node, right? So I guess I only have 2 leaf nodes. Okay, great. So this is my complete binary tree, and yeah, I think that's it. We have completed our visualization, we have completed search, we have completed upload, and finally, just to summarize, the time complexity of searching any file, let's say you're searching CMK file, the time complexity is going to be big O of log n. Okay, or you can write it as like this. Okay, so this is the time complexity of searching any file in a binary search tree. Great. So I hope you liked this video. I hope you enjoyed it. I really need feedback from you that whether you want more such full stack videos based upon data structures, right? So our focus will not be completely data structures. Our focus will not be completely full stack development. Our focus will be to understand both and apply them in real life. Okay. So let me know what next you want to learn. I have planned a video where you can actually use hash maps as a data structure and create a simple application. Okay. So let me know. And till then, I'll be waiting for your comments. Till the next video, keep coding, keep innovating, and thanks a lot.